Start, sir. Start the class, sir.
Okay. Good morning, students. Welcome back. So this is the second part of our states of matter. This is gases and liquid state. Okay. So far, prominently, we have discussed about the intermolecular forces. Okay. And the next topic from this unit is thermal energy. So what is this thermal energy? So it is the energy of the body or any gases or any solid or anything, what is matter, arising from the motion of its atoms and molecules. Okay, so how the movement or motion is created in the molecules? So it is by increasing the temperature. For example, if you take ice, the movement of particles or atoms or molecule is not there. Means H2O molecules are not in the movement. So if you want to create a movement in those water molecules, so definitely you have to give some heat energy. So the energy that comes from temperature of the heated substance is called as thermal energy. So heat is generated, heat is produced to the system so that the particles will take that heat energy. Kinetic energy is increased, means that thermal energy or heat energy is converted to uh, kinetic energy so that the particles move. So this movement or the kinetic energy is taken as a measure for thermal energy. So that is the thing. So that's why the energy that comes from the temperature of the heated substance is called as thermal energy. So, from this definition, we can say that it is directly proportional to the temperature of a substance. So, if more temperature is there, means more heat is given, more temperature will be there, then more thermal energy. So it is a measure of average kinetic energy of the matter and is responsible for the movement. This movement of particles is called as thermal motion. So we can take the example here. See, if a solid is taken here, solid which is present at minus 20 degrees Celsius or centigrade. Okay. Now, if heat energy is given, means see here from here to here, minus 20 to 0, temperature is increased. So the temperature is increased means the solid is now ready to convert into liquid state. At this point to this point, transformation is taking place from solid to liquid. Now here it is a liquid substance. And again from heating from 0 to 100 degrees centigrade means increasing of temperature from 0 to 100, the liquid is gaining temperature, liquid is gaining movement, more movement is created from here to here. Now then after 100 degrees centigrade, this liquid transformation into gas takes place from here to here transformation. Then after 100 degrees centigrade, the liquid is converted to gas. Only gas will exist after this temperature. So this is nothing but we are giving thermal energy by heating the substance. Thermal energy is taken and so that kinetic energy is created. So from solid to liquid, movement of particles is more. Okay, so kinetic energy is increased. From liquid to gas, more kinetic energy is there. More, means kinetic energy is increased more by thermal energy. So this we can simply see the curving heating curve for water. This is graph for the water. Okay, and intermolecular forces tend to keep the molecules together, but thermal energy of the molecules tends to keep them apart. Okay, so if temperature is increased, what happens? Kinetic energy is increased, movement of the particles are increased. But what about intermolecular forces? Prominently, intermolecular forces are van der Waals forces, means attractive forces. These attractive forces try to keep the molecules together. But if you increase thermal energy, what happens? Molecules move more, movement of the molecules more. So they move here and there. So that intermolecular forces and thermal energy are contrast. So But whether the substance should stay in liquid or gas or solid state is a balance between these two forces, two energies, simply intermolecular forces and thermal energy. More thermal energy is created, then suppose if solid is there, more thermal energy is given by some external force, then means external things means we suppose we heat that system, then the solid will convert into liquid, means we are giving more heat energy or thermal energy. So if the thermal energy is not there, if we decrease the temperature of that system, intermolecular forces increases, so that liquid converts to solid. So the balance, which is more, intermolecular force is more, the substance tries to come back to the solid, liquid to solid state like that. But if thermal energy is more, temperature is increased, then definitely the liquid will convert, I mean, solid convert to liquid and liquid convert to gas. So the three states of matter are a result of balance between the intermolecular force and thermal energy of the molecules. So this is simply about the thermal energy. Next, coming to the gaseous state. Okay, so prominently we will discuss about gaseous state in this unit. So you all know about the gaseous state, means simple the properties, physical properties of gaseous state. So it is the simplest state of matter, and we all live in the atmosphere of gases, that is troposphere. So coming to the physical properties, gases are highly compressible, they create pressure, they have low density because see, density than the solids and liquids means the volume occupied by the gases is more, but the mass is less compared to solids, and mass is same, but the volume occupied by the gases is more than solids and liquid. As density is equal to mass by volume, volume is more, so the density is less for gases. So these are about the simple properties, that is shape. Gases acquire the shape of the container, volume also, it acquires the complete volume of the container. If you put some 10 ml of gas in 100 ml of a beaker, then it will acquire the 100 ml of the beaker. Okay, so gases mix completely in all proportions. See, can you mention a homogeneous, can you differentiate a gases mixture as homogeneous mixture and heterogeneous mixture? Okay, some simple but important point this is. So gases mix evenly and completely in all proportions. Suppose if you take any non-reacting gases in some container, can you mention whether it is homogeneous or heterogeneous? No, because gases mix evenly and completely. So definitely gases mixture is homogeneous only. Okay, it will be same throughout the mixture, that if two or three gases are taken throughout the mixture, same composition will be there. It is unlike the heterogeneous solutions. Okay, so some laws are there which will govern the properties of the gases. So their behavior is governed by some general laws which are discovered and as a result of experimental studies. So what are those properties which decide this behavior of gases are nothing but like pressure, volume and temperature of gases, and mass also. Okay, pressure, volume, temperature, mass of the gas, they interrelate in these gas laws which will decide the behavior of the gas as well as state of the gas, means which in which state that substance or matter should exist. So prominently we have four laws: Boyle's law, Charles' law, Gay-Lussac's law, and Avogadro's law. So coming to the first law, first gas law, Boyle's law. So I think you are well aware of all these laws in your lower means 10th class, I think. But again, we are just giving going over through all these laws. Okay. Boyle's law. What is Boyle's law? According to Robert Boyle's law, so at constant temperature, pressure of the gas is inversely proportional to the volume of the gas. Okay, and remember, at constant temperature. So this is very simple. We can simply assume this, but this law is not simply assumed. It is given after many experiments only. It looks very simple, but deriving this law is not simple. Okay, this included many experiments by Boyle. Okay, see the image here. Some gas is taken in a cylinder with a movable piston. Okay, now the volume of the gas is some little this much. Okay, but if you decrease the pressure, okay, means you are moving the piston upwards. Okay, moving the piston upwards indicates increase in volume, as at the same time pressure is decreased. Okay, coming from here to here, let us see from here to here. So the volume is this much, and if you apply pressure from upwards, okay, we are applying pressure from upwards, so that the volume of the gas is decreased. It is nothing but pressure is increased or not? Yes, definitely. If you apply some force, pressure is created on the gas molecules, volume is decreased. So the same proportionality is taken here. Pressure is inversely proportional to volume, inversely proportional to volume at constant temperature. Constant temperature. So this is nothing but Boyle's law. So if you rearrange this equation, P and V is taken onto the left side. PV is equal to constant. PV is equal to K. So we can also take for P1 and V1 is equal to P2 and V2, and means with the different conditions. P1 is equal to P2 V2. So P1 by T1 is equal to P2 by T2. So this is from same Boyle's law. Okay, observing this graph, it is taken uh, pressure versus volume. Okay, volume is taken on x-axis and pressure on y-axis. So simple. At high pressure, see here, this is at high pressure, and the pressure is decreased. As the pressure is decreased, volume is increased. Pressure is decreased downwards. Pressure is decreased downwards. See, pressure is decreased. Pressure is decreased. Pressure is decreased. From here to here, the pressure falls, and from here to here, volume increases. This is also shown in this cylindrical form also. Okay, so that is about the Boyle's law equation. And coming to the isotherm, very important, you will get some questions from these isotherms or isochores or isobars in your competitive exams. What is isotherm? Isotherm is a line or curve or graph drawn at constant temperature. If you maintain a particular temperature and you do some a process on a system, okay, maintaining a particular temperature, and you're doing some process on the system, and if you plot a graph based on that experiment, that particular graph you can mention it as isotherm. For example, in this experiment, a particular temperature is maintained, for example 30 or 40 degrees centigrade, and you are performing some process. See, what is the process you are performing here? You are decreasing the pressure. You are decreasing the pressure from here to here, here to here, and increasing the volume. So this is a particular process you are doing, some experiment you are conducting. Okay, and this is conducted at a particular temperature, and you have drawn a graph like this. See the points: first point, second point, third, fourth, fifth, 6 points. Means at some different particular pressures and volumes, you have plotted a graph. Okay, this is plotted at a particular temperature, maintaining a single temperature. Okay, so that this graph is considered as a isotherm, and you have to mention a particular temperature. If you are telling that this is an isotherm, definitely you have to mention the temperature. For example, this graph. So these graphs are isotherms. Okay, so some gas is taken or some system is taken. First, they have taken 600 Kelvin temperature. Okay, so 600, at 600 Kelvin temperature, pressure is decreased and volume is increased. The graph will be like this. Okay, the red color one. The graph will be obtained like this. Then the temperature is lowered 400 Kelvin. Okay, again at 400 Kelvin, pressure is decreased, volume is increased. So this red color curve is also following the Boyle's law. This green color one is also following Boyle's law, and blue color one also. But these three are different conditions, different temperatures. Okay, at 600 Kelvin, this is the curve, and 400 Kelvin, this is the curve. All the three curves look similar, but what is the difference? The difference is at 600 Kelvin, the pressure is here and the volume pressure is here. But at 400 Kelvin, the pressure is here, and but the volume is different. See the from here, if you draw a line downwards, the volume comes here. But for 400 Kelvin, the volume comes here. So the difference in volume occurs at the same pressure for different temperatures. So if you change the temperature, what is changed? What is changed? Pressure and volume or pressure will be changed, but the pressure versus volume curve will be same. Okay, so for a particular system, don't confuse. Let me explain you again. For a particular system, you are considering 600 Kelvin once, and you are performing the experiment, so that you are getting that red color line. Okay, next you have taken another experiment, means same experiment, different condition, that is 400 Kelvin, and you have plotted another graph, that is green color line. And the third one, 200 Kelvin temperature is taken. At that particular temperature, again the same experiment is conducted and plotted on the graph, blue color line is obtained. Okay, so and all the three experiments are included in one graph. Now this is that graph. So why this graph is drawn like this? Why? What is the use taking this graph? Why don't we plot three graphs separately? Yes. So to differentiate the curves at different temperatures, this plot is taken. So you may get a question like this. For example, see this graph. The same graph is taken here, P versus V at different temperatures. Now this T3 is greater than T2 is greater than T1. So for if you consider this, 600 Kelvin is T3, 400 Kelvin is T2, 200 Kelvin is T1. Okay, so T3 600 Kelvin is greater than 400 than 200. That is taken here. So simply this graph is given to you. Okay, they may ask you the increasing and decreasing orders of these temperatures. So that is one simple uh, competitive question. Okay, this graph is given, and they may ask you to give the increasing or decreasing orders of T1, T2, and T3. Okay, so highest temperature curve will be here. So that you have to remember. Okay, this another graph is taken. This is also isotherm only. Pressure versus 1 by V is taken. See, pressure versus 1 by V. So simply pressure directly proportional to 1 by V, we have to say. So any proportional means A directly proportional to B, if you take, that will be a straight line passing through origin. Any graph. P, here P proportional to 1 by V we have taken. So P directly proportional to 1 by V. So if PV is taken, P and V are inversely proportional. But P 1 by V is taken, this is directly proportional graph. So that is again passing through the straight line, passing through the origin. And here also, this red color one is the highest temperature line. So that's why T3 is greater than T2 and greater than T1. This is also one of the competitive exam question. Okay. So next coming to Charles' law. So Charles' law, Charles and Gay-Lussac both have conducted experiments in hot air balloon technology, and they have given you the Charles' law and Gay-Lussac's law. So coming to the Charles' law, so this is temperature volume relationship at constant pressure. Okay, see at constant pressure, volume of a system is volume of a gas is directly proportional to the temperature. Okay, so if we take the same thing in the graphical form, so volume is taken on y-axis and temperature is taken on x-axis. It is a straight line passing through origin. Okay, so straight line will be obtained like this. So here, for a fixed mass at constant pressure, volume of a gas increases on increasing temperature. So the same thing is here. So, but one thing is observed here is how much increase takes place, how much increase of volume is taking place. So it is given here like this. It is found that for each degree rise in temperature, volume of gas is increased by 1 by 273.15 of the original volume. Okay, for each degree raise in temperature. For example, let us take a gas is present at 0 degree centigrade. Okay, let us take gas present at 0 degree centigrade. Volume is V naught. Okay, and from 0 to 1 degree centigrade, from 0 to 1 degree centigrade, you are increasing the temperature. Then volume you consider as V1. Okay, then what is V1? So V1 is equal to V naught plus V naught by 273.15. Means how much volume is increased? How much volume is increased? The volume of the gas is increased by 273.1 by 273.15 of the original volume. If the original volume is V naught, if the original volume is E naught, then increased volume will be V naught by 273.15. The increased volume is V naught by 273.15. Now the total volume at 1 degree Celsius will be V naught plus V naught by 273.15. Okay. So this is the observation. Okay. So suppose the volume of the gas at 0 degree centigrade is V naught. Now, whatever you heard in the last slide, you put it on the paper like this. Okay. So suppose the volume of the gas at 0 degree centigrade is V naught. Then volume at 1 degree centigrade is equal to V1. Let us consider as V1 is equal to V naught plus V naught into 1 by 273.15. Okay. We are taking 273. Understood? If the volume is 1, then what is the increase in volume? 1 by 273. But if volume is V naught, what is the increase in volume? V naught by 273. Total volume will be the original volume plus increase in volume. That is V naught plus V naught by 273. Okay, that is the condition. Then volume at 2 degree centigrade is equal to, means from V naught 0 degree centigrade to we have increased 2 degree centigrade. Temperature is increased by 2 degrees centigrade. Volume also should increase according to Charles' law. Then V2 is equal to V naught plus V naught plus V naught plus V naught into 2 by 273. Okay. How much temperature is increased? 2 degrees Celsius. So that's why this 2 is taken here. So if the volume is increased by T degree centigrade, okay, now we are not telling 1, 2, 3 degrees centigrade increase. We are simply taking T degree centigrade. So volume at T degree centigrade is equal to Vt is equal to V naught plus V naught into T by 273. Okay. So from here, if you take V naught common, Vt is equal to V naught into 1 by 1 plus T by 273. If you take LCM, Vt is equal to V naught. So this is the relation. If you take LCM, 273 plus T by 273. Okay. So this is the final volume. This is the final volume at T degree centigrade. Okay. T degree centigrade means from initial volume to final volume. Suppose initial is 30 degree centigrade and the final temperature is 60 degrees centigrade. What is the increased temperature? 30 degrees centigrade. So this Vt means V at 60 degrees centigrade. Then V naught will be V 30 degrees centigrade. Understood? Okay. V naught means may not be 0 degree. So therefore, if you consider V1 by V2 is equal to, so V1 by V2. So V1 by V2 means at different temperatures. Suppose 30 degree centigrade, 60 degree centigrade. That is equal to T1 plus 273 by T2 plus 273. Okay, according from this equation we have taken this. So that is equal to, if 273 and 273 is cancelled, T1 by T2. So V1 by V this again V1 by V2 is equal to T1 by T2. V1 by T1 is taken cross multiplication. So cross V1 T1 is taken here, V2 is taken upwards on the right side. So V1 by T1 is equal to V2 by T2. Then it is simply V by T is equal to constant, or V directly proportional to T. Okay, nothing but V directly proportional to T, nothing but Charles law. So V1 into T2 is equal to V2 into same this one. So this is how Charles law is derived from experiment. Okay, so at this stage we can mention Kelvin temperature or Kelvin scale of temperature or absolute temperature scale. It is also called as thermodynamic scale of temperature. Okay, so this simply gives you the relation between the centigrade and Kelvin temperature. So many in many calculations we should consider the Kelvin scale of temperature. Okay, Kelvin temperature scale we have to consider, means temperature has to be taken in Kelvins, not centigrade. But generally we measure the temperature in centigrade. Okay, but in our calculations in this chapter you consider Kelvin, means wherever you get temperature in centigrade, convert it into Kelvin scale. Means that 0 degree centigrade should be converted to some dash Kelvin. How much? How will you convert? How will you convert means, see here, temperature in Kelvin is equal to 273.15 plus temperature in centigrade. So T naught is equal to 273.15. So this T naught is equal to, okay, see here, 0 degree centigrade is equal to 273.15 Kelvin. That is considered as T naught. Okay, 273.15. T1 is equal to 273.15 plus T. So wherever you get, okay, I'll in the next class I'll give you this conversion. Okay, now just understand this. T is temperature in centigrade. Okay, for example, 27 degree centigrade is given. Convert it into Kelvin. Okay, now temperature in Kelvin T1 is equal to 273.15 plus 27 degree centigrade. It comes around 300 Kelvin. Now 27 degree centigrade is equal to 300 Kelvin. What is the conversion factor? 273.15. Add 273.15 to the centigrade temperature, then it will become equal to Kelvin temperature. So next graph is isobar. Isobar means just like isotherm. Therm means therm means temperature, heat. So isotherm means at constant temperature. Isobar means bar. Pressure is mm, pressure is measured in bars. Okay, one of the units of pressure is bar. Okay, that's why isobar means, remember, pressure. So means graphs at constant pressures are called as isobars. The name, remember, name indicates pressure. Iso means same pressure. So the graphs drawn or taken at constant pressures are called as isobars. So the lowest hypothetical or imaginary temperature at which gases are supposed to occupy zero volume is called as absolute zero. So absolute zero temperature is minus 273.15 degrees centigrade. Students, remember this point. For example, see here, this is a isobar for some system. Isobar volume versus temperature is taken. Again, volume is directly proportional to the temperature according to Charles law. So there will be a straight line, okay, passing through origin. So there is a straight line passing through origin, but different pressure conditions are taken. So at a constant pressure P1, at a constant pressure P1, volume is increased and temperature is decreased. That is taken as this line. Okay. Now next experiment. In the next experiment, pressure is put as P2 constant and again the experiment is conducted and P2 graph is drawn, that is the blue color one. So like that P3 line, P4 line means at four different pressure conditions, don't think that pressure is changed. We are mentioning that pressure is constant, but we have taken four different pressures. How? It is not like that. At particular temperature, at particular pressure P1, this line is taken. This line is obtained. Another graph is there where at particular P2 pressure, a graph is drawn. These are four different graphs. Students, these are four different graphs. But to compare the lines at different pressures, all the four lines are taken in one graph. Understood? Four different experiments. These are four different experiments. So I used to feel the same confusion when I was in intermediate. That's why some of the students may feel difficult to understand this why four lines are obtained and considering same pressure. Isobar, the name indicates. So that's why I'm explaining many times. Okay. So now which pressure is more and which pressure is less? It is this order again is important for your competitive exams. P4 is more, P3 is less. So P4 is greater than P3. So this line is obtained at high pressures. At high pressure, see at high pressure, this line is obtained like that. Okay, then the if you extrapolate downwards the line, okay, it will touch the volume, that is zero volume. Okay, if you extrapolate the line downwards to the zero volume, it reaches a temperature that is minus 273.5 degrees centigrade. Okay, the temperature is taken in 0 degree centigrade, students. So means this up to here the line ends actually. But if you want to touch the zero volume, you have to draw the line downwards and touch the zero volume. This is origin, zero volume. Then what is the temperature it is? The temperature is minus 273.15. So this temperature is called as absolute zero. Okay, what is absolute zero temperature? Minus 273.15 degrees centigrade. At this temperature, kinetic energy of the any matter becomes zero, so that all the substances will be in the solid state and we consider it as zero volume. Zero volume means matter will not disappear. It is a zero volume means almost it can't, it is like it is coming to compact, maximum compact structure. That is considered as zero volume. It don't think that zero volume means the substance will be disappear. Okay, it is the maximum, it is, you can say that it is the minimum volume of any matter. Okay, and any matter if it is having, it is in the minimum volume state, is nothing but definitely it is a solid. Okay, so all the gases laws, all the gases obey Charles law at very high temperatures and low pressures. Okay, so what is this point? What happens if pressure is increased and temperature is decreased? So that we will see in the next coming slides later. So coming to Gay-Lussac's law. So the third law is Gay-Lussac's law. Very simple. At constant volume, pressure directly proportional to temperature. So it is similar to your Charles law. At constant pressure, volume directly proportional to temperature. Here, at constant volume, pressure directly proportional to temperature. So here we simply conclude this. P1 by T1 is equal to P2 by T2. P by T is equal to constant. That equation should be there. P by T is equal to constant K. Okay. So pressure versus temperature graph is taken. As I have already said, any A versus B directly proportionality is taken. There will be a line in the graph which passes through origin, straight line. So isochore is taken. So what is this Gay-Lussac's law? At constant volume, isn't it? If you perform an experiment at constant volume and plot a graph, that graph is considered as isochore. Isochore means at constant volume. Okay. See here isochores, these are different results of experiment at different volumes. Okay, so remember this order of volumes. So V4 is greater than V3 than V2 means at the highest volume the graph will be obtained like this. Uh, it is touching the temperature line means at x-axis means pressure is very less. More volume, less pressure. Remember, more volume here V4 is the highest. No, more volume, pressure will be less. So see, the pressure will be less for this graph. This line, red color line, the pressure is less. So this graph is called as isochore. Coming to the other law, Avogadro's law. Okay, so this Avogadro's law gives you the volume and amount relationship. Okay, volume and amount. Remember, students, amount in your further studies or earlier topics, amount of any gas, amount of any substance is taken in terms of n. That is nothing but number of moles. Okay, number of moles. Why we have to take the amount in terms of number of moles? Why not amount or particles as one particle, two particles, three particles? Okay, can you calculate oxygen as two oxygen molecules are there, three oxygen molecules are there, like that? No, we will tell 2 moles of oxygen is there, 0.5 mole of oxygen is there, or 3 moles or 1.5 1.025 moles of oxygen is there, like that. Why? Because there are many particles. If you consider, if you take a handful of water, okay, that handful of water consists of, see, the range 10 in 10 to the power 23. Okay, 1 mole is equal to 6.023 into 10 power 23 means after 1 you are having 23 zeros. Can you count that? Imagine. No, it's difficult. So we want to study the particles in simple digits, not very large digits. So that's why taken, we are converting the molecules into moles. Okay, number of molecules we take in the form of moles. So what is the relationship here? Number of 1 mole is equal to how many molecules? So see here, 1 mole is equal to 1 mole is equal to 6.023 into 10 power 23 molecules. So this constant is called as Avogadro's constant. Remember students, this is very much necessary for all your calculations. Okay, many competitive questions will require this. Okay, no simple question is there without one such kind of constants. So if you do some problem, definitely it includes two or three equations, two or three constants, like that. Simple questions will not be there, no. Okay, so if you have to calculate problems on mole concept, definitely you should know this constant. So that is 1 mole is equal to 6.023 into 10 power 23 molecules, which is nothing but Avogadro's constant. Then what is this Avogadro's law? Says that it states that equal volumes of all gases under the same conditions of temperature and pressure contains equal number of molecules. So see here, volume is directly proportional to number of moles at constant pressure and temperature. At constant temperature and pressure, volume directly proportional to number of moles. So this statement gives you good information than this equation. Okay, it states that equal volumes of all gases under same conditions of temperature contains equal number of molecules. Okay, equal number of molecules and maybe equal number of moles. Very simple. Coming here, argon, oxygen and nitrogen. Three different gases are taken at 1 atmosphere pressure and 273 Kelvin. Understood? 1 atmosphere pressure and 273 Kelvin. All the same temperature and pressure is maintained. How many moles of gas are taken? 1 mole of gas is also same. 1 mole of gas is taken for all the three gases. 1 mole of gas means this 6.023 into 10 to the power 23 molecules of gas are taken for these three. Then see the volume. See the volume. All the three gases are occupying 22.4 liters only. Interesting. This is really interesting. But consider the mass, students. Mass is different. 40 grams, 32 grams, 28 grams. These are different gases. Masses are different. But equal number of moles of gases occupy equal volumes at a particular temperature and pressure. That is nothing but this Avogadro's law. If you increase the volume, number of moles, or if you increase the number of moles, volume increases. That's how you consider. If you increase the number of moles, volume also increases. Understood? It states that equal volumes, okay, equal volumes of, vice versa you can take, equal volumes of all the gases will occupy equal number of, will contain equal number of moles. Okay, I hope you understood. So again, V directly proportional to N means if you increase the number of moles, volume increases. If you increase the number of moles, volume increases. Again, this line is a straight line which should pass through the horizon. Then from this proportionality, from this equation, you can write V1 by N1 is equal to V2 by N2. Okay. So how can you calculate the number of moles, students? How can you calculate number of moles? Number of moles N is equal to, for any substance, number of moles you can calculate by this formula. The number of moles N is equal to weight of the substance W in grams by molecular weight of that particular substance. Simply N is equal to W by M. So you have to, I have given you two questions. You calculate in your classwork. That is, calculate the number of moles of 60.4 liters of oxygen. And another question, calculate the number of moles of 0.44 grams of oxygen. Okay, complete these two questions today. And next, coming here, uh, we have to see the standard temperature and pressure conditions. So standard temperature and pressure conditions. See, what is standard temperature and pressure? 273.15 Kelvin or 0 degrees centigrade and 1 atmosphere pressure. These two consider standard temperature and pressure. Okay. Again, once again, I'm telling 0 degree centigrade or 273.15 Kelvin. We have already seen this relationship, students. 0 degree Celsius or centigrade is equal to 273.15 Kelvin. Okay. At this temperature and 1 atmospheric pressure is considered as standard temperature and pressure. So 1 mole of any gas at standard STP will have the same volume. Okay. So at STP, molar volume of any ideal gas or any combination of ideal gases is occupying 22.4 liters. Okay. Remember. So in the last slide, we have also seen here 1 mole of gas is taken. Okay. 1 mole of gas is taken or not? 1 mole of 3 gases are taken. At what temperature and pressure? At STP condition temperature and pressure. 1 atmosphere temperature pressure and 273 Kelvin. Okay, at STP conditions, 1 mole of any gas, 1 mole of any gas is occupying how much volume? 22.4 liter. 22.4 liter. Understood? So this is nothing but at STP, molar volume of any ideal gas or any combination of ideal gases is 22.4 liters. Means per mole means 1 mole of any gas occupies 22.4 liter. It means. So from all the above three laws, we will derive ideal gas equation. So what is ideal gas equation means? Combination of all the three laws. That is Boyle's law, Charles' law, or Avogadro's law. Okay, Boyle's law, volume is inversely proportional to pressure at constant number of moles of substance and temperature. And Charles' law, V directly proportional to T. Avogadro's law, V directly proportional to N. So we are taking V directly proportional to N T by P. Okay, V directly proportional to N T by P. So then if you remove the proportional, then we have to include a constant. Okay, V is equal to R N T by P. Okay, R N T by P. Then if you take P to left side, then PV is equal to nRT. Okay, PV is equal to nRT. See here, PV is equal to nRT. P is pressure, V is volume, N is number of moles, R is gas constant, and T is temperature. So from this, if for 1 mole of gas, okay, if for 1 mole of gas, if N is equal to 1, you can write this relation as P1 V1 by T1 is equal to P2 V2 by T2. Okay.
Madam, close the session. Thank you.
Okay, sir. What is R? R is gas constant. Okay, gas constant R has different uh, units. In if you consider P, V, and N, if you consider P, V, and T in different units, then R will also be different. Okay, based on different units, R has to be taken like this. R values may be 8.314 joules per Kelvin per mole. Generally, we'll take this R value, or in calories, like 1.9 means 2 calories per Kelvin per mole, and this will liter atmosphere per Kelvin per mole is also we generally take based on the problem that is given, means pressure, volume. Based on pressure, volume, the R value has to be taken like 0.021. Okay, thank you, students. Let us conclude here. We'll continue tomorrow.
Thank you.